Hi, now we are in the section 6, so this is kind of the extra part. Right? You can use what we have learned so far to perform any kind of hypothesis you want. And I think that's enough for the let's say informal or for the easy statistical procedure. But now we're gonna introduce two more. It's just to know to fill the gaps on what else are we missing from the image. So we have start from the critical value. Right, so some of you might notice that if we have the curve, like if we have the distribution, so let's say yes, it is a mu and then sigma over square of n. If we have the distribution and we have the significant value, let's say 0.05, and then let's suppose the hypothesis is in the form of, that should be the mu 0. It's in the form of greater than or equals to, which is the area on the right. So we form the left test. Right. So if we know all these numbers, doesn't it mean that we can find the value, right, such that the area is 0.05? Oh, sorry. In this case, let's say the area is the confidence level. And so given all these information, we don't have to know the sample mean. We can say, oh, if we have the curve, we can find the point where the area on the left is exactly that. In other words, in the formal, where is that the probability that x is less than some value, so is alpha. We don't need that p-value yet. Okay, we can find x. Okay, that's the second problem we encounter when we start studying the standard normal distribution. We can find the value of x, and so that means we can know in advance that what value will be there. Okay, so if we go to there, okay, so remember that we can also put the value on the pink box, which is the area, and then we get the value of x. In this case, it is minus 1.6. And so we know in advance what is the threshold and what is the cutoff. So you might ask, why don't we just do this instead? Okay, so once we have all these numbers, then we can find this value, which we will call the x crit. It's critical, it's CR. So the critical value. So we can find the critical value in advance. And once we get the sample average, we can simply compare that average to the critical value and see if it's to the left, then of course that the area, the p-value is going to be smaller than alpha, because by the inequality or by the shape. If the sample mean is on the right of that critical value, then we can just say, oh, that the area, the p-value is going to be higher, so we can just do not reject. And of course we can do that, and this is exactly this part. And so we can find this critical value, right? And then once we get the sample average, you can simply compare that, and that means we have an alternative way to perform the hypothesis testing. Right, so if you find the critical value, then in conclusion, before you compute the p-value, which in this case you don't have to compute, right? After you analyze the data, right, instead of finding p-value, we can just say, okay, if x bar, right, if the sample mean is at least the critical value, right, in this case it's on the right, then we can conclude that we do not reject. That's the same as saying that the p-value is greater than alpha. And if the average is less than the critical value, let's make it greater than or equal to, okay, then this is when we reject the null hypothesis. So that works, that's totally fine. Yeah, that's an alternative way to make that. But yeah, let's make a remark here. That's the good thing is that yeah, you can do that. The trade-off, not a bad thing per se, but it's a trade-off. Is that if you give, okay, if you say, okay, let's say the sample mean is 1.5 and the critical value is 104, and then you say and then you give all that conclusion, right? Then of course the hypothesis testing is correct, nothing wrong with that. But when you look back at this number, you might be worrying, is that value close or far away from the critical value? And because again, the numbers themselves do not tell the difference on the scale of the normal distribution. Okay, so you might wonder how is it by chance that this happens to be higher, or is it higher by a mile or by a large number? Right, so this works, but you lose a sense of the probability that we had when we compute the p-value. Because if we say the p-value is 0.1, we can understand right away that okay, 0.1 means we have 10% chance, about 10% chance to get a sample of that value or smaller. But here you lose that sense of the ratio of the percentage. But nonetheless, that works. And you will see in a moment that we indeed need a critical value to compute the error for the type 2. Yeah, type 2 error. So yes, that's a text that I had before, so you can pause and read again and compare that with what we have above. So there's a box for just to conclude the things that I have said. Right? So a critical value is defined as the value where you get where the p-value is exactly alpha. And then once we have that, then we can find, this is the formula on how to find the critical value. Maybe we use the old formula for the same value. If you fix the area, you can find the point. And the area to the left of that point is exactly alpha. So this is for the left tail test. For the right tail test, you can see that you simply flip that and that and that, and then you get everything else working perfectly fine. But for the two tail test, let's make sure that we have these kind of numbers. So I think I missed something there. Yeah, I missed that. This should be like or x greater than x cubed. Maybe because here that has to represent the total area on both left and right. And here there are actually true critical values because we need to point on left and right. So here we define the critical value as a positive number. And then the other side or the mirror side is going to be the negative number of the same value. But the critical value is the point where the area on both sides is equal to alpha, the cutoff or the threshold for our p-value. And then this it has to be divided by 2. So you can compute the critical value in the same way. But that's a critical value. I don't have an example here. Okay, yeah, so we will see how to use the critical value to determine what determine the type 2 error